Alright everyone, so this chapter also has a little part where it talks about pseudoscience, and I gave a lecture on this at my college a few months ago. I am not going to give you guys the entire lecture. I'm going to definitely hit the high points and the things that I want to point out, because you don't have an hour to hear me rant about things I see on the internet, but I do want you to definitely know some stuff when you see it, so that in the future there will be less problems. Okay, so there are lots of things that people will try to do to mess up what it is you're seeing on the internet. Basically, they're going to show you stuff to make you believe what they want you to believe, not what things actually say. And that's true for a lot of people. Okay, some people do it unintentionally, some people do it intentionally. But you're going to see a lot of things where you have little bits and pieces or misleading stuff, and you just have to know to look for some of this stuff. The people who won't do this to you, the people who won't lie to you about this kind of stuff, are scientists. They're the ones who will report their things accurately. And they'll show resources, and they'll have data to back up what they're saying. And their data will be accurately represented and will make plausible sense, as you'll see here as we go through this presentation. So one way that people will mess with you, and it's common, is what's known as cherry picking, right? So they just pick one thing out of a large set of data and say this part is representative, and that's all that matters. Nothing else matters, right? So they take little pieces, and they only take the piece that they want to show you, and the rest is left for you to figure it out. Okay? And that piece that they show you will support whatever it is they're saying, but they won't show you the entirety of what it is that they're trying to say. So make sure that you know what you're looking at. So if you're looking at something particularly like climate data should span hundreds, if not thousands of years, not 5. Okay, or you're not going to have 5 or 10 years in terms of climate. Doesn't matter. It doesn't mean that much. You need to be able to see global trends across hundreds of years or tens of hundreds of years. Same thing with financial data. Small pieces of financial data are meaningless as well. Stock markets, things like that, increase, decrease all the time. I could take out a little piece of one little part of one day and say, look how much it increased. I mean, it's just that one little piece. It doesn't mean anything for the rest of it. But if someone only showed you that one piece, then that's all you get. Be wary of everything that acts like it has an agenda. Scientists don't have an agenda except to understand the nature of the world. Lots of people have agendas where they will use science and things that they report to back up their agenda, and they will do it inaccurately. For example, people will claim, by showing you this part you see here in the circle, people will claim that the sea ice is returned to normal. It's essentially the same, but if you look then a few months later, a few years later, it's very different. And we can pull out one little piece of climate data over the course of less than 10 years, and it doesn't look like the climate is warming. Or I could show you something that's all remarkably true, but obviously incorrect. Right? Overconsumption of water can lead to excessive urination. 100% of murderers have drank water. These are all things that, sure, they're probably true, but this obviously has an agenda. It's obviously trying to make you believe something by reporting things that are true, but don't really have a lot of meaning. Another thing you need to watch out for, and this is one thing that I'm probably going to focus on throughout the class, is that you need to know if you look at a graph and it's misleading. Graphs can be taken out of context all the time, and it's particularly true if you're trying to make a graph of something. You need to know if you're graphing it correctly so that it can be understood. right? So here are global temperatures from 1880 to 2015. So it's got the amount of time that I told you it needed. But global temperatures don't change by 110 degrees plus or minus over the course of time. Small amounts of change matter. And so if they change by even, tenths of a degree, that matters. But if I show you this, it looks like, oh, there's no change over all that time. Okay, but if you zoom in, you can see there's a big change. Right, almost 2 degrees matters, and 2 degrees in 100 years. Two things I want you to see here. I got both of these images off the internet. The first one just has no information whatsoever, just gives you what it is. The second has a source at the top. And again, I just gathered both of those. They're both representing the same thing, or supposedly representing the same thing. Can't really tell with the first one. Bar graphs, this is on the news all the time. I see this all the time. Bar graphs. You go 6 million in one, 7 million in the other. Sure. That 1 million, 1 million difference sure is a lot bigger than the 6 million that are in the bottom. Right, so I took this data and remade it, and this is kind of what it should look like. Doesn't look like that much of a difference. This sure does. Another bar graph example. This is back when gas was way more expensive than it is now. Hopefully it doesn't get that expensive again. But notice those taxes and how much the cost of gas actually represents. Okay? This is what it actually should look like. That's what that 20% tax actually looks like. This value they actually give that is that 20% is essentially true, but that 20% looks like this. It doesn't take up almost half of the image. This is misleading, and it's intentionally misleading. The goal is to make you feel like you're paying more in taxes than you are. Another thing that people will constantly show you, and this one's tough to spot all the time. Sometimes it's blatantly obvious, as you'll see in some of these examples. But the idea that correlation, two things happening together, does not imply that one of them causes the other. Okay, so we can talk about situations where this would be true, and it's very likely, and situations where it's obviously not likely. First of all, Internet Explorer, it just kills a lot of people apparently. Rates of Internet Explorer going down meant that murder rates went down. The less people used Internet Explorer, the less people died of murder. I mean, this makes no sense. There's no link between the two. There's no reason to believe that an internet browser is going to keep people from, murdering anyone else. It's completely absurd. But the two show a correlation. But that doesn't mean that they imply one and the other. There's one that's a little bit tougher. Rates of autism and organic food sales. Okay, so you could show that there's a reasonable relationship here, and this might give you reason to study something like this. But just reporting this relationship and saying that this is true without any more evidence is not enough. Okay? And what likely actually happened is that organic food became more popular, autism became more prevalent and more noticed over time, and so you see a general increase in both over the course of those years. Here's one where you see a correlation where, as the measles vaccine became taken into use, the rates of measles cases went down. This is where you see a correlation, okay, albeit a negative correlation, but a correlation between two variables that actually do have a causal link between the two. Causal link because that causal link was studied. One was intentionally used to cause the other. And we can show that it works. Now, another great one is to always remember that Photoshop is a real thing, and people will just Photoshop stuff, regardless of what they tell you. Okay, and here's a good example that I see all the time. Mars will be as visible as, or as big as the moon in the sky, or it'll appear that way. Okay, the next time you see it won't be for another 200,000 years. Wow. You guys, this will never happen. Call it out the moment you see it. Okay? If this were to ever happen, we have a lot more problems than having to wait 200 years to see it again. Mars should never be that close to the Earth. If it is, it's coming at us, right? It's coming right for us. We're about to have a problem. Okay? No matter how close Mars is, even when it's closest approach, it will still appear to be a faint red dot in the sky. Okay. Another thing, and this is just one little piece that I added on at the end of the lecture, another thing is that you will see people quoting famous people with quotes that were not by those famous people. Don't believe this. Look this up. This is so easy to check, it's ridiculous. Don't perpetrate ridiculous things like this. Always question what you read. Check sources. Make sure that what you're doing is true. Don't trust everything that you see on the internet, and don't trust everything that is the first Google search. It's just the most popular result. It doesn't mean it's the correct result. It does not mean it's the answer you're looking for. The internet and the resources that it contains are only as good as the person who is using it. If you don't understand what you're seeing, if you don't understand what you're reading, if you don't understand why what you're reading matters, especially in terms of science, then you can't possibly understand when something is true or not, or when something is trying to fool you. Here's just some reputable sources, things to look up. I'm going to include this PowerPoint in with your lecture materials. And then go watch this video. You'll be surprised at how you respond to it.